So thank you for the introduction. So I'm indeed Jenni Kontkanen from CSC, IT Center for Science, and I have started there in the beginning of this year as climate strategist. And I will introduce you LUMI, which is the pre-exascale supercomputer that we have in northern Finland. So in this presentation, I will first discuss the story of LUMI so far, and then later go more in detail on the LUMI capabilities. So first, a very brief introduction to Euro-HPC initiative. So Euro-HPC joint undertaking pools European Union's national resources in high-performance computing to acquire and provide world-class supercomputing and data infrastructures in Europe, and also to support research and innovation. And the Euro-HPC declaration has been signed by 32 European countries, and the first generation of Euro-HPC systems was announced in June 2019, and then 3 pre-exascale systems were announced. And actually in this session we are here about all these systems. So I will naturally talk about one in Finland, so LUMI, and then there will be Leonardo in Italy and Mare Nostrum 5 in Spain. LUMI supercomputer has been funded jointly by Euro-HPC joint undertaking and LUMI consortium. So LUMI consortium is a consortium including 10 countries with strong national HPC centers. So you can see the LUMI consortium countries in this map. They are colored with the blue there. And there also you see the location of our data center in Kajaani, where LUMI is located. And resources of LUMI will be allocated per the investment to the member countries, and a share of the Euro-HPC, which is 50% of the resources, will be available for all European researchers. And the shares of the LUMI partner countries will be allocated by local policies to researchers in that country. So LUMI is one of the fastest supercomputers in the world. So LUMI is an HPE Cray-X supercomputer manufactured by Hewlett-Packard Enterprise. It has a sustained performance of over 375 petaflops, and this makes it one of the world's fastest supercomputers. So the partial system of LUMI was listed in May this year with 152 petaflops as third in top 500 list, and it was also third in Green 500 list and also in the HPCG list. And LUMI is a modern platform for high-performance computing, artificial intelligence, and data analytics based on GPU technology. And this way, LUMI can enable scientific breakthroughs in different fields. So LUMI has been designed to be a versatile tool that can be used to tackle a wide spectrum of use cases within different fields. So for example, in climate research, LUMI can help in building these, for example, digital twins of Earth in connection to Destination Earth or similar programs. In addition, LUMI can help to reach breakthroughs in, for example, data science, plasma physics, life sciences, material science, and humanities and social sciences. Then about our LUMI data center in Kajaani. So actually the facilities of LUMI are also quite special. So LUMI is located in the premises of an old paper mill. There you can see the hall where the LUMI is currently, how it looked like before, after the paper mill has been shut down. And there you see some schematic of LUMI. And what is really special about this place is also that we have there 100% a hydroelectric energy available. And also, thanks to the cool climate, there is 100% free cooling available. And then also the waste heat of LUMI can be reused to heat the district around. And this means that we can actually consider LUMI to have a negative carbon footprint, as when LUMI is operational, then they don't need to use as much fossil fuels to heat the district around. And this is of course quite special, and we are proud of this. Yes, here I actually had a video on LUMI. Maybe we watch it for a while, as we are quite short on time, and no need to watch it completely, but it just shows how LUMI looks like. You probably don't hear the sounds properly. But yeah, let's see when I stop this. But yeah, so this is basically how it looks like. So it's quite nice looking. Maybe we move forward. Okay, so then I will discuss more LUMI capabilities. Okay, so LUMI is a tier 0 GPU accelerated supercomputer enabling high performance computing, artificial intelligence, and high performance data analytics. LUMI's main partition is a GPU partition, LUMI G, that has over 10,000 AMD Instinct GPUs. LUMI also has a supplementary CPU partition with more than 200,000 AMD CPU cores. And these different partitions of LUMI are connected with a high-speed interconnect with HPE slingshot technology. And there is a possibility for combining different resources within a single run or even within a single job. So for example, you can combine CPU and GPU nodes or use both of them. LUMI also have a data analytics partition for data analytics and visualization. That's called LUMI D. Then there's also LUMI F, which is flash-based storage layer with 8 petabytes. There's also LUMI P, which is cluster storage with 80 petabytes. And there's also LUMI O, which is an object storage service with 30 petabytes. There will be also LUMI Q, the quantum processor, and LUMI K, container cloud service. This slide illustrates LUMI timeline. So the system procurement started in November 2019, and it lasted until August 2020. Kajaani data center preparations were ready in the beginning of 2021, and the first phase of LUMI started in the end of quite towards the end of 2021 with LUMI C, P, F, and D with an early access platform. Since then, LUMI has been in pilot use with extended beta testing, and there has been a regular access to LUMI C partition and development access to LUMI G partition. Now then, during this year, LUMI G has been gradually deployed, and now we are actually very close to the final configuration of LUMI, so we expect it to be ready in early November, and then LUMI will be also generally available. On LUMI, we aim towards enhanced user experience. So for example, in addition to traditional command line interface, we support high-level interfaces. So for instance, seamlessly integrating Jupyter notebooks and such to backend to LUMI. There also is a rich stack of pre-installed software. And in addition, there will be a curated large reference dataset available and maintained, which is called Datasets as a Service. And there will be also support for handling sensitive data, for example, those that are subject to GDPR. Yes, okay, I'm checking. I thought that I had the slide on LUMI user support. okay, maybe I accidentally removed that. I will then just briefly mention that we also have a LUMI user support team, which includes members from different LUMI countries, and the user support team will, of course, offer support in usage of LUMI, but also organize all kind of training. Okay, then about getting LUMI resources. So as I already said, these EUR-HPC resources for LUMI are available to all European researchers, and these can be applied via EUR-HPC calls. In addition, researchers in the LUMI consortium countries can apply resources from the local resource providers. Yes, and they will be given according to national policies. And LUMI resources are allocated in terms of GPU hours, CPU core hours, and storage hours, and the resources are procured in terms of preparatory access projects, development access projects, general access projects, and extreme scale projects that should be mostly GPU hours. Then I will just briefly mention some LUMI features that can potentially enhance weather and climate research workflows. So those include continuous integration, continuous development pipelines for model and dataset versioning, interactive LUMI partition for visualization and analysis of massive datasets, also microservices platform with an access to the parallel file system. So this is the LUMI-K. So this enables interactive and batch job orchestration, workflow management, and running different data mover utilities. There's also a possibility for running notebooks and Julian compute partitions, and also there are dataset repositories. So then I already come to conclusions. So currently there is unprecedented amount of computational resources and capabilities available for European research and innovation through EUR-HPC. And one of these resources is LUMI, which is designed for broad range of user communities and workloads with an enhanced user experience. And weather and climate modelers are among the key user communities of LUMI. And for example, LUMI will be one of the main platforms for European Commission's Destination Earth program. So then, if you are interested to hear more about LUMI, you can follow LUMI on different social media channels, and also have a look at the LUMI supercomputer webpage, where you can also find all kind of technical details and documentation. Thank you.